Well, here we go. We've talked about addressing. We've talked about when and where we use them. We've talked about IGMP. And now it's time to talk a little bit about Protocol Independent Multicast and close this thing out. So this is part 4 of 4 in Multicast series. And we are going to talk specifically about the layer 3 side, some of the issues here. So what PIM has to do is similar to what we're doing with IGMP. Remember, we're trying to figure out who's going to be a member in the group. We're going to try and figure out where we need to forward this traffic. And then we're also going to try and figure out what's the best way to forward this in the most efficient way. And so we're going to use, in the layer 3 topology, something called Protocol Independent Multicast. And PIM has a couple of modes associated with it. So we'll go through some of the detail on each one of them. First up is the dense mode. Now, PIM dense is all about saying, well, look, we've lost hope. We have no idea what we're doing. We don't know where anybody's going to be. And so we're just going to spam multicast traffic everywhere. So every router in the topology is going to take part in this multicast stream. And so what you're essentially saying is that I really don't care where the end nodes are. I'm not worried about efficiency at this point. We're just sending it everywhere. Every router is going to be a part of this. Sparse mode says, well, hold on a sec. How about we do this? We've got a complicated routing topology. There's no reason to send multicast traffic where we don't need it to be. So here's what we're going to do. We're going to say to a router, if you want it, you can come get it. So that's the opt-in part. And if I want a particular multicast stream, then I'm going to talk to a particular router or routers called rendezvous points. So routers go out and get a particular multicast stream from the rendezvous point. And this gets us to the idea of pruning. What happens is that you're building a tree. So we're used to the idea of layer 2 trees, right? Spanning tree topologies, routing protocol topologies where we try to eliminate loops and we try to do some redundancy and we try to handle efficient load balancing and things like that. So we built sort of this image of the topology from the perspective of a particular router so that we can forward traffic to the destinations. And sometimes we have failover and things of that sort. But from the perspective of a particular router, you can very much think of the forwarding as a sort of tree structure because you don't use all interfaces to get to every destination. The same thing is true here. What we're going to use is the multicast information base to forward things out particular interfaces because that's where we know multicast learners are. Once we've established that, we know now that hosts have the ability to join and leave the topology anytime they want to. Or I should say join and leave the multicast groups anytime they want to. And remember that it's easy to get turned around here a little bit. You might have several multicast groups being added and subtracted, and each one of them having nodes added or subtracted. And for that reason, we also have timers. Timers are associated with multicast groups and their membership, and so that should a timer expire, a router doesn't have to forward the traffic to that destination out that particular interface anymore. Both PIM dense mode and PIM sparse mode dramatically change the way routers handle the forwarding of traffic. Now, this is because the routing information base or the forwarding information base is unicast in nature. That's what routers are worried about. It's a unicast routing table. It's unicast destinations that we're worried about. It's destination networks, not this sort of mystical, magical collection of nodes that could be part of the same group even though they're not on the same interfaces. And so we have to keep track of this new requirement for forwarding in something called the Tree Information Base, or TIB. It's got a slightly different structure in the two modes because, as I said, in sparse mode, not every router has to participate. And in that case, we need a rendezvous point so that routers can go out to a particular location and pick up that traffic. Now, to be clear, another router is going to be acting as the rendezvous point. So when you think about it, routers have to keep track of where the sources are. They have to keep track of any host that needs to be a part of that group. And then if you're operating in sparse mode, it also has to keep track of any rendezvous points that might be out there. In dense mode, you don't have to worry about that. Just like IGMP, there are a collection of RFCs associated with PIM, and this is the list. You can see that there are different RFCs for the different modes. That's because if you take a look at them, they're fairly substantial documents. The router alert option is part of the signaling to tell a router, hey, listen, it's time for you to pay attention. Actually, this is a flag that's actually set that says to the router, you've got to listen to this particular messaging. Now here is a PIM Hello, and there's a couple of things that I want to point out to you. On the left-hand side here, we've got the RFC general format. PIM messages have a particular multicast permanent address associated with them, 224.00.13, so no other service should be using that particular address. It's one of the reasons why I chose, for my multicast stream in these examples, an address that was high in the range. So this happens to be a PIM Hello. It's pretty straightforward. It just says, well, look, I am participating in multicast routing. Is anybody out there able to do the same thing? And by the way, I happen to be a designated router for the multicast stream, and here is my priority. And there's my hold time for any particular multicast stream that I'm keeping track of. All right, so that's PIM Hello. Now, a PIM Join says, between routers, hey, listen, I see that you are a multicast router just like me. Here's what I'd like to do. I'd like to join a particular multicast stream. So if you have knowledge of this multicast stream, send it my way. And so here we've got the 239.99.99.99 address. Again, remember that was the multicast source that is used by 172.31.31.15 in our previous example. This is the multicast source, and this is the router signaling that they need to be, they've got a host downstream, right, that has signaled its membership, and they need to be a part of the multicast stream. So please forward it our way. And again, they're using 224.00.13 to signal to their neighbor. This one happens to come from 172.30.30.253, and it goes to anybody that will listen. So here is a routed topology. We got 3 networks here, and we can see our source there all the way on the left, 172.31.31.15. And then we've got this normal unicast topology, and there's the full routing tables that would be required, the full unicast routing tables that would be required in this particular topology. So a very good question becomes, how in the world would I get a multicast stream all the way on the other side of the topology to 172.29.21.1 that wants to listen to this particular multicast stream? As you can see from the routing tables, there is no way that those routers would be able to forward to that destination. They simply don't know how. And the answer is that we have to give them a configuration that says not only are you doing protocol independent multicast, in this case you're participating in a particular mode of PIM, but also that a particular interface has to be willing to forward and receive multicast requests. So let's take a look at what that router config looks like. Here we have the 2 routers involved here. This is router A and B in this particular topology. And you can see that these are the left and right routers, respectively. They're both connected to the 30net in between. And what I've said on both of these is that you're using IGMP version 3 and you are in PIM dense mode. Now that's the spam, right? The search spam a lot. In this particular case, I didn't have a big problem with getting too crazy with the multicast traffic. But that's it. That is the full config. So a multicast router configuration is pretty straightforward. It starts with turning on IP multicast routing on the router itself, and then describing how you want the interfaces to behave. And in this case, again, PIM dense mode and IGMP version 3. I could have left IGMP versioning off in this particular case, but they might not have been doing the version that my hosts needed. So I decided to specify. Well, what's the impact of all this? Let's take a look at our multicast routing table. So you can see that we've got a show IP M route instead of show IP route. And if we take a look, there's an entry for 239.99.99.99. And we've got a rendezvous point there, non-existent because we're doing dense mode. And then we've got the timers associated with how long we've known this particular route. But there you have it. That's how the routers understand where they're supposed to send this traffic. And we've got an interface associated with this as well. Just for fun, I put in there in the bottom that there is another multicast address that's in here that doesn't have anything to do with what we're doing. Remember that 239.255.255.250 was SSDP, but 224.0.1.40 we haven't talked about yet, and that is just the auto discovery for rendezvous points. But again, we're not doing anything with that here, and so that's blank. Well, that closes out our multicast video series. This is just hitting the high points of the chapter. So far, we've talked about multicast addressing for IP version 4 and IP version 6, the tie between layer 2 and layer 3, some IGMP goodness, and then, of course, protocol independent multicast. That should be enough to give you a head start on starting your own multicast topology. By the way, I forgot to mention that I used VLC as my video streaming source and as my client for all of the multicast stuff that I did for the chapter and for these videos. Well, next up, I'm going to publish a couple of videos on network address translation. We'll tear into that, which corresponds to another new chapter in the Packet Guide to Routing and Switching. So again, free to those that have the ebook. And if you want the print version, you can go ahead and pick that up. And that will be what we do next. Thanks very much for watching. Thanks for listening. And may your packets always reach their destinations.